Okay, so we left off with completing the square, right? And we used imaginary numbers. So let's go ahead and apply our mathematical operations, our addition, subtraction, multiplication, and division, right? Our operations. So we're going to do addition and subtraction at the same time because just as if these were x's, you just combine like terms, right? Remember that? Suppose, I wanted to add x plus 5 plus x minus 3, right? You would, because of the plus sign, you would drop the parentheses and you would just start adding like terms. It's the same thing with the I term. Okay, same thing with the I term. Because this is a plus sign, we're going to go ahead and drop the parentheses. I have 4 minus I plus 3 plus 5I. Now I'm going to go ahead and just combine like terms. So here I have 4 and my 3. These are my, remember, the order. The order was, I'm going to rewrite it. Okay, so my first one was real numbers or the perfect square. Good. And then I put my plus or minus in there, right? And then we... Great. Next comes the imaginary, which is square root of -1. Awesome. And then we're going to times it to the leftovers, right? And that's our irrational number. Okay, so I'm going to make sure that every answer has to be in that order. Okay. So when I'm combining like terms here, we're doing addition. The first one I want is my real number, or the square root of a perfect, right? So I got 12. And then, let's see, I have, just as if this was an x, okay? There's a 1 in front of there, right? So there's a 1 in front of the I. My coefficient is 1. So I have a -1i and a positive 5i gives me a positive 4i. There's my answer.
Super easy.
Yep.
Wouldn't a negative times positive be a negative?
We're not multiplying. We're just combining like terms.
Oh,
Part 4, the next section, we're going to be multiplying. Okay. Right now, we're just doing addition and subtraction. All right. Here, I do have a minus sign I need to distribute, right? So I've got 2 plus 8i minus 3, and then minus 12i. Now I'm going to combine my like terms. Let's see, I've got my real numbers here, 2, -3, -1, -4i, good.
Wait, and when this is what the first one, 4 plus 3 is 7.
Yeah, it's 7. Why did you multiply them, Kalina? You told me to multiply them. It's all your fault. Wow, I'm making a lot of mistakes today. Ben had to correct me on 2 of them last hour. Okay, so that's it. Addition and subtraction. Pretty easy, right? Then we have multiplication. So let's go ahead and multiply. Okay, the first one, I have a number in front of parentheses. What do I have to do?
The number inside.
Yeah, distribute, right, to the numbers inside. Okay, 2i, just think of it as like an x. Okay? Think of it as an x. I got 2x times 4 plus 5x. Okay, and distributing it. So 2i times 4 is what?
8.
Good. Okay, 2i times 5i.
Squared.
Good. You caught that, didn't you? It's squared. Because if I were to take 2x times 5x, you get 10x squared. Okay, now this is the fun part. We went over that I equals the square root of -1, right? If I were to square both sides, if I were to raise both sides to the power of 2, I would get I squared equals -1. Just like the square root cancels out the power of 2, the power of 2 cancels out my square root. So I know that I squared equals -1. We could take this, we could take all of our problems now a step further, right? Because I squared equals -1. So if I replace that I squared with -1, now I'm going to go ahead and show you every step in this problem. We don't have to do it all the time. 8i plus 10 times -1, because I'm replacing -1 for the I squared. So I get 8i. Now, 10 times -1 is -10. So I'm not going to put a plus -10. I'm just going to put -10 minus 10. Then, it's not in the right order, right? I have to put my real number first, minus -10, and it's an integer, so it's a real number. And then I have a plus 8i. Now, after just a couple of problems, many of you are going to go from this step to this step, because after a couple of some repetition, it's pretty easy to do that. Questions?
In that last, your answer there essentially, could you take that whole thing and square it and do the same thing with the 8? So get -100 plus 8i squared.
We're going to do that right now. Okay? I'm going to show you how you could multiply that. It's squared, basically. Okay. Actually, it's number 12. We're taking that and we're squaring it. Okay, so we'll do that in number 12. All right, so let's look at 10 first. Before we get there, I want to look at number 10. If I have a binomial, suppose I had, I don't know, x minus 3 times 2x plus 5. What do we do to get the product? Multiply, right? Multiply. Say that again. Not simplify anything. You're thinking of distribute. Okay, we're going to distribute. But when we have a binomial times a binomial, there's a special thing. There's a special thing we call to multiply these. It is distribution, but it's. Remember the method.
Isn't it 12?
First, outer.
Yeah, 12.
Oh, you said FOIL? Okay. Yep, it's FOIL. Okay, you use FOIL to get the product. A binomial times a binomial. Okay. So we're going to use FOIL on this. Okay, so the first, I'm going to take 3 times 2, gives me 6. Outer, 3 times 6i. I'm going to use different colors. So 3 times 6i, positive 18i. Inner, negative 1i times 2, negative 2i. And last, negative 6i. Oh, be careful. I have an I times I. I squared. Okay. Now, when we FOIL, we always have 2 middle terms to combine, right? The inner outers. Okay, so I have 6. I have a plus 18i and a minus 2i.
That would make it 6.
Good. A plus 16i. Now, you could go ahead and just bring this negative 6i squared, but we know what I squared equals, right? What does I squared equal? Okay, so we have a negative 6 times a negative 1. What is it? Positive 6.
Then we have to switch it around and stuff.
Right. Well, first we have 2 common terms, right? Positive 6. Add them together. 12. That's our real number, our square root of perfect. And then
We move the 16 to the front.
to the next position. Here's my answer. Okay? No, because remember the order. Where's my order? My order is the real number first, which is 12. Or you can think of it as the square root of 144, right? And then my imaginary number, 16i. It's my I term. That's my I. And then I don't have anything left over. The irrational. Okay? Want to do 11? Of course we do. Okay, first term. 4 times 4 is second outer.
Negative 4.
Good. 4 times negative 1i is negative 4i. Inner,
Positive 4.
positive 4i. And last,
Negative I squared.
okay. We always have to combine the middle two, right? What happens to these?
They cancel.
Okay, so I get 16. And what's I squared?
Negative
So it would be a positive.
So it'll be a plus 1, right?
And we add that to the 16. equals
Awesome. 17. Now, did you notice something in this? Look at the 2 binomials here.
They're both the perfect square.
Actually they are. I never thought of it that way. But they're almost exactly the same, aren't they? Almost. Yeah, one's a plus and one's a minus. We call these, even though I spelled this last hour, I still can't spell, conjugates. Conjugates. Okay, these are complex conjugates. Notice if I ever want to get rid of an I, if I have this if I have this 4 plus I, if I ever want to get rid of that I, multiply it by its conjugate. It will always get a real number. That's a hint for the next section. Now, Asher, we can do this one, number 12. 7 plus I squared is 7 plus I times 7 plus I. Foil it. You can't, because they're two terms, you can't just multiply each term. You have to FOIL it. So, 7 times 7 is?
49.
Outer,
Right.
7i. Inner,
Plus 49.
and last,
Plus I squared.
good. All right, so we have to go back, combine these, substitute in -1. So I have 49. 14i. And then -1. Real number first, 48 plus 14.
Isn't it 49?
49 minus 1 is 48. Combined like terms. You see them? Okay, questions? And the last operation is division, right? And like everything else in mathematics, we can never leave a variable in the denominator, a square root, and negative exponents, and that kind of thing. Well, you can never leave an I in the denominator. To get rid of the I, remember what I said? Multiply it by its conjugate. Okay? That's how we get rid of it. We get a real number. And here's the conjugates. Okay? Turns it into a real number. So I'm going to multiply this. Remember, these are two terms. Anytime you have two terms in either the numerator or denominator in a fraction, make sure you put them in parentheses. So I'm going to turn this denominator into a real number by multiplying it by its conjugate, which is 2 minus I. I can't just multiply the denominator. I have to multiply the numerator so I don't change the value of the fraction, right? Okay. So I'm going to go ahead and do the denominator here. See, 2 times 2 is 4. Now I know the outer and the inner are going to cancel, right? Because they're conjugates. If you want to just forget about it, you can and just multiply the last. I'm going to do it just for teaching purposes. The outer is negative 2i. The inner is positive 2i. They cancel out. Could have just left them out, right? And then the last, positive 1i times negative 1i is a negative I squared. Negative I squared is negative 1, so we get a positive 1, right? 4 plus 1 is 5. Then I distribute, because I only have one term, right? 8 times 2, 16. 8 times negative 1i, negative 8i. It's not too bad, right?
So wait, Mr. Dave, the reason you couldn't have done that for number 9
To do, what did you want to do the number 9?
Put it in parentheses and square it.
Well, you can. If you want to get, now, what's your purpose?
I want to get rid of the so I can make it a negative.
If you want to get rid of that I, you would have to multiply by its conjugate, negative 10 minus 8I. That will get rid of the I. Anytime you want to get rid of the I, you multiply it by its conjugate. But it's more complicated than that because you're changing the value when you do that just right off the bat. If it was, you'd have to do it as a fraction. I'll show you after class. Okay. All right, 14. I want to get rid of the I in the denominator. So I'm going to multiply it by its conjugate, which is 5 plus 3I. So I also have to multiply the numerator by its conjugate. So let's go ahead and do the denominator. So 5 times 5 is 25. I'm not going to worry about the outer inner because they're going to cancel out. So I have a negative 3. I'm worrying about the last. Negative 3I times positive 3I. The negative 9I squared. I squared is just going to change the sign, right? So I got 25 plus 9, which is 34. Now I'm going to have to FOIL the top because these are not conjugates, right? All right. 1 times 5 is 5. Outer, 1 times positive 3I. Inner, plus 20I. Good.
Oh, we're supposed to FOIL it?
Yep, you have to FOIL because I'm doing a binomial times a binomial. And then 4I times 3I. Good. Okay, let's do some simplifying. See, I have a 5 and a 20, right? It's 25.
Where'd the 20 and I go?
Is that an I? Did I miss it? I thought I missed an I. Thank you. Yeah, that seems much better. There's an I there. Oh, I wish I can undo. There's an I. So these are not like terms. Yeah, I knew something was wrong right when I did it. Okay, so I have 5. Let's see, now I combine the i's. The 3I and the 20I is 23I, right? Oh, now I got too much sticky tape on there. And then, let's see, I've got I squared is negative 1 times 12. Going to make that negative 12.
Add negative 1, 5, and you get negative something. Negative 7.
Good. Yes. Because integers are real numbers. There's my answer. Wasn't that fun? Fun with Math Day. And the last problem, new stuff for the last thing of the year. That's new. Electrical circuits contain several components, resistors, inductors, and capacitors. Overall resistance is known as impedance. Z, overall impedance, can be found by adding all the components together. Each resistor is a real number. So this is real number. That's our perfect square, right? Square root of perfect. Each inductor is imaginary, so that's our Li. And the capacitor is imaginary, so we got a minus Ci. So here's our formula. It's easier than you think. So our resistor plus our inductor, right, Li, minus Ci. So my resistor, all I'm going to do is start substituting in these ohms, right? So that's 6 plus my inductor is 10I, minus my capacitor is 5I. Combine like terms. 10I minus 5I. Boy, was that hard.
We do that for the other ones, like here.
Uh-huh. So our resistor, I'm going to write the formula up here. You just add both numbers. So my resistor is 13. I have 4 and 5, so I have 4I plus 5I. And my capacitor is 7I.
And we add.
So that's 9I. So I have my 13. 9I minus 7I. 2I. There you go.